All right, so today we need to identify the difference between prisms and pyramids. These two are prisms. That's because there's two bases. There's two that are equivalent. There's that triangle and that triangle. There could be this rectangle and that rectangle on the other side. When it comes to pyramids, there's only one base. This base, and it comes to a point, and one base, and it comes to a point. So instead of being this bottom part and growing up to match it, what this does is it just grows up, but it only comes to a point. Pyramids, like the Egyptian pyramids, and prisms. All right, so let's go over each individual one. This is a rectangular prism. There is a front and a back. There is a right side and a left side, and a top and a bottom. And the top and bottom, of course, are equivalent. The two sides are equivalent, and front and back are equivalent. So this is called a rectangular prism. When you open it up, it looks like this. So it was like this to begin with. When you open it, you have the top and bottom, which end up spaced apart like this. You have the front and back and the two sides. Now when it comes to rectangular prisms, these two are equivalent, these two are always equivalent, and these two are always equivalent. So you have three equivalent rectangles, two sets, or three sets of two. So these two are same, those two spaced out are the same, and these two are the same. Now you get to choose which are the bases. So base does not mean bottom. So these two do not have to be the bases. They do not. The front and back could be the base or the two sides. You just have to choose. In this case, we can make these two our bases. So we find the length and width of this piece, and you have two of them that match. They skip right here. Two bases for every rectangular prism. Now we're going to look at a triangular prism. Triangular prism because the bases are triangles. So you just draw out a triangle, and that would represent your base of two equivalent sides. The bases are and always will be congruent. Okay, now what you need to realize is because it's a triangle, that means it has three different sides, or could. Now let's visualize this. If I took this and landed it on its side, these are still its bases. Its bases do not change because it is a triangular pyramid. The triangles are always the bases. It will never be a rectangle. So again, triangular prism. So let's visualize this. It doesn't matter if it's top or bottom, left or right, if it's laying on its side or what. For example, a tent. Walk in one side, you got the back side, you got the two sides that would be in there and the bottom. If you open these up, what you get is this shape. There are your two bases. It does not have to be bottom. This is the bottom of the tent, but that is not your base. This is a triangular prism. That means there's two congruent, and these are the only two that have to be congruent. If this is an equilateral triangle, then this length, and this length will all be equal. If this is an isosceles, meaning only two sides are equal, let's visualize these two are equal. That means these two sides, when they close up, those two sides would create the equivalence. So if these two sides are only equal, those two are equal when this one would be different. If it is a scaling triangle on the side, that means this length, and this length are all three different. That means this length, and this length that would end up touching it when they close up would all be different also. So the only two that are consistent, equivalent to each other, are these two, and those are the triangular prisms. They are the triangles. That means there's two bases, and that does not mean bottom. The bottom of the triangle of this triangular prism, if I actually put it together, would be the bottom of a tent. But the bases are the front and back, two equivalent sides. All right, so let's move on to pyramids. These are pyramids because they come to a point like the Egyptian pyramids, and they only have one base and one base only. This one is a rectangular pyramid because the base is a rectangle and it comes to a point. Now because it's a rectangle, that means it has 4 sides. So let's give this as an example. Here is my pyramid, and the base, of course, is a rectangle. So when I open it up, what I have is these 2 equivalent sides, these 2 equivalent sides, and 1 base. Only 1, because it's going to come to that point. So this is, again, a rectangular pyramid. These 2 equivalent triangles, those 2 equivalent triangles, and 1 base, which is a rectangle. Okay, last but not least, we have a triangular pyramid because our base is a triangle and it comes to a point, and that is this. Now, because the base is a triangle which has 3 sides, that means it has 3 triangles that are off of that piece. So if you open it up, it then looks like this figure. The base, there's only 1 base and 3 sides. These are triangles. They do not have to be equivalent. This is the only base. That's the only one that will be the base. So it's one triangular. That's why it's called a triangular pyramid. All right, now let's summarize. The first 2 are called prisms, while the second set are pyramids. Prisms because they have 2 bases each. The first one is a rectangular prism because your bases are rectangles. The second one is triangular prism because your bases are triangles. The third one is a rectangular pyramid because it comes to a point and because it has 1 base that is rectangular. The fourth one is a triangular pyramid because it has 1 base which is triangle and it comes to a point.